Machine learning, the extraordinary science of teaching computers how to learn from experience instead of following rigid pre-written instructions, is quietly transforming the world around us in ways most people barely notice. It is the invisible force behind the technology that defines modern life. From Netflix automatically recommending the perfect movie, to your phone unlocking when it sees your face, to self-driving cars navigating busy streets with precision and confidence, to medical systems scanning images and detecting diseases faster than any human eye could. At its very heart, machine learning is about recognizing patterns in chaos, feeding a computer vast amounts of data, allowing it to make predictions or guesses, then comparing those guesses to reality and improving step by step, mistake by mistake, until the system learns how to understand the world on its own terms. Unlike traditional programming, where every rule must be hand-coded and explicit, machine learning allows systems to discover their own rules by studying examples, uncovering mathematical relationships so subtle that even experts might not see them. There are three great schools of thought within this world of artificial learning. In supervised learning, we give the computer labeled data, for example, pictures of cats and dogs, each clearly marked, and it learns the relationship between what it sees, the input, and the label, the output. In unsupervised learning, there are no labels, no guidance. The system explores raw, unmarked data, searching for natural clusters, patterns, and hidden structures on its own. And in reinforcement learning, the most human-like of the three, the computer learns through trial and error, by experimenting, receiving rewards for good actions and penalties for bad ones, gradually building a strategy that maximizes success, much like how a child learns by playing. But what truly fuels all of this is not magic, it's data. Data is the oxygen that lets these systems breathe. The quality, diversity, and size of the data determine how intelligent a model can become. If the data is biased, the model will be too. If it's incomplete, the model will make poor assumptions. Everything begins and ends with data, how it's collected, cleaned, and understood. To make this real, imagine you're building a model to predict house prices. You feed it thousands of past examples, the size of the home, its location, its condition, and its price. At first, the machine makes wild guesses, completely wrong, almost random. But each time it compares its guess to the real price, it calculates how far off it was. It adjusts its internal settings, a web of mathematical weights, and tries again and again and again, thousands of times, until it begins to see the invisible logic connecting all the variables. Eventually, it can predict the value of a home it has never seen before. That process is called training. And when it performs well on unseen data, that's when we say it has generalized, when it has truly learned the underlying pattern rather than memorizing examples. This endless cycle of guessing, comparing, and improving is the rhythm behind modern intelligence. It powers everything from the spam filters protecting your inbox, to chatbots holding conversations, to systems that detect credit card fraud in milliseconds. Every smart technology you interact with today, from voice assistants to photo tagging, is built on this same principle of machines learning from feedback. Behind the scenes, the tools that make this possible are evolving rapidly. Python has become the universal language of machine learning, valued for its simplicity, flexibility, and the rich ecosystem of libraries that make experimentation effortless. TensorFlow and PyTorch handle the heavy lifting for deep learning, while scikit-learn simplifies classic tasks like classification and regression. Pandas and NumPy make data processing fast and elegant, and platforms like Google Colab, Kaggle, and Hugging Face have made machine learning accessible to anyone with an internet connection. This democratization of AI means that powerful tools once locked inside research labs are now freely available to curious minds around the world. Every machine learning project follows a structured rhythm. Collect your data, the raw material of intelligence. Clean and prepare it, removing errors, duplicates, and gaps that could distort results. Train your model by feeding it the data and allowing it to adjust and learn. Evaluate it on new, unseen data to test how well it performs. And when it finally performs well, deploy it into the world, inside an app, a website, or a production system, so others can benefit from its predictions. This process isn't a straight road, it's an endless loop of improvement. You build, test, fail, adjust, and build again, just like the way humans learn through feedback and repetition. But the frontier is moving fast. Deep learning and generative AI are redefining what machines can do. We've moved from systems that analyze data to systems that create. Neural networks inspired by the structure of the human brain can now write poetry, generate art, design buildings, and simulate voices. Transformers, the architecture behind today's large language models, can understand context, nuance, and emotion across billions of words. What once sounded like science fiction is now woven into everyday tools. Still, every leap forward brings new challenges. When machines learn from human data, they absorb not only our intelligence, but also our biases, our blind spots, our flawed history. Algorithms can discriminate just as easily as they can enlighten. So the ethical questions become unavoidable. Who is responsible when an AI makes a harmful decision? How can we ensure transparency in systems that even their creators struggle to explain? The answers to these questions will shape the moral foundation of the AI age. Yet, the potential upside is immense. Machine learning can accelerate drug discovery, personalize education for every learner, predict environmental changes, and optimize agriculture to feed billions more efficiently. It's not about replacing humans, it's about amplifying what humans can achieve. For newcomers, the best path is to start small and stay curious. Learn the core ideas, how data becomes insight, how mistakes become feedback, and how improvement never really ends. Use tools like Google Colab to explore data interactively, or Kaggle to join global competitions where experts share their work. Study how others solve problems, then build your own small experiments. Don't wait until you know enough. Machine learning is something you learn by doing, failing, and trying again, exactly like the machines themselves. Because in truth, machine learning isn't just about algorithms, it's about a way of thinking. It's about seeing patterns where others see noise, about using data to refine intuition, about approaching problems with curiosity and discipline. Every dataset tells a story, and every model is an attempt to understand that story's rhythm and structure. As models become more advanced, they're not just solving problems, they're beginning to reason, to create, to imagine. But here's what most people miss. The true power of machine learning doesn't lie in the code or the hardware or even the math. It lies in the perspective it teaches us. Once you start thinking in terms of data, feedback, and iteration, you realize that everything, from personal growth to business strategy, follows the same pattern of learning from mistakes and improving through experience. Machine learning is a mirror reflecting humanity's own process of discovery. It reminds us that intelligence, whether human or artificial, is not built in a moment. It is earned through curiosity, failure, and the courage to keep learning. That's what makes the future of machine learning not just powerful, but